Hey there, Mr. Wilford here. I just want to go through Chapter 6, Section 4 with you, factoring polynomials. Now, we've factored different things in the past. We've learned how to factor quadratics by reverse FOILing or factoring out the greatest common factor, things like that. What we want to do now is take a look at factoring different kinds of polynomials. Remember that anytime you are dividing anything, such as numbers even, if the remainder is 0, you have a factor. Same thing is true for dividing polynomials. If you end up with a remainder of 0, then we have those factors, those polynomials are the factors. There's something here called the factor theorem, and basically it kind of just goes through that. Take a look at these couple of examples. Basically what you're looking at here is taking, in this example, x minus 3, and taking the opposite of that number, 3, and then using synthetic substitution or synthetic division. And if your remainder is 0, then it is a factor. Like this example B, the remainder is 0. So this would be a factor. X plus 4 would be a factor of that polynomial. If it is not 0, then it is not a factor. So take a look at those couple of examples there, and that will help you decide if you have a factor or not. Now, actually finding the factors, there are a couple formulas here, and we've talked about the difference of squares before. We're talking here about the sum of two cubes and the difference of two cubes. So now we're talking about something cubed. And basically, if you have a perfect cube plus a perfect cube, you can rewrite it using this formula. If you have a difference of cubes, same thing. Take a look at these two examples and try to follow along. Basically, I'll just quickly read through example A. This first one here, notice I can factor out a greatest common factor of 5x, and then what I have left is x cubed and 8. And 8 is a perfect cube, and so is x cubed, so I can rewrite it like this. And then I'm just really following this formula up here, letting x be the a and 2 be the b, and just plugging those things in, and then just rewriting it here and cleaning it up. Same thing happens down here, except it's a difference of cubes. Let me know if you have any questions with those problems there. What I want to do is make sure that I get through these kinds of problems here, 4 through 9 from your textbook, because I don't really have those in the note packet, and I want to make sure that I talk about this a little bit. This is called factoring by grouping. And basically, I'm going to look at number 7 here. Basically, what you do is, if you notice, you have 4 terms. So here I have 4 terms in number 7. What you do is you take that polynomial and you group the first 2 terms and the second 2 terms, and then you just look at each group separately. So I'm going to look at this first group, and you want to factor out the greatest common factor. So here I can actually factor out a 2x squared. So what do I have left? If I take the 2 out and I take 2 of these x's, I'm left with just x. And then I have a minus, and then I take the 2 out, I take the x squared out, so I'm left with a 1. Okay, I need the 1 there to hold the place. In the second group, I'm going to factor out actually a negative 8, and then notice what I have left. If I take the negative 8 out, I have an x left, and then if I take a negative away from here, a negative 8, I'm going to be left with a negative 1. Now, this is the key part right here to factoring by grouping. These two things have to be the same. Okay, what you're left over with, those two things have to be the same, or factoring by grouping will not work. Then what you do is you take this thing here, the 2x squared, and the negative 8, and you put those together. 2x squared minus 8, and then you take only one of these, x minus 1. Now, sometimes you'll actually be finished right there. However, with this one, I can factor out in this first group a 2, and I'm left with x minus 4, x squared minus 4, and I still have this x minus 1. And then I notice I have a difference of squares here, so I can actually keep going. X minus 2, x plus 2, and then still the x minus 1. So this actually right here is my final factored answer for number 7. Again, that's a little bit much, but try to follow along. Take it step by step, and if you have any questions, please let me know. Thanks.